Hey guys. In this video, we're going to talk about how we know the number of solutions that we're going to have to a quadratic equation based off of something called the discriminant. So first of all, we know that in general, we're going to have two solutions to a quadratic equation so when this is 0, that would be an x-intercept. So when it's asking for the x-intercepts of a graph, it's just saying how many solutions do we have when we set this equal to 0, which is what we've been finding, right? We've been getting everything equal to 0 so that we can use either the zero product property or quadratic formula. So the x-intercepts just means setting this equal to 0, which is exactly what we've been doing. So let's talk about that. So the value of the discriminant. What's the discriminant? Well, the discriminant is this thing, which should look familiar because it's part of the quadratic formula. This isn't going to tell you what your solutions are, but it is going to tell you how many, and I'll show you why. If the discriminant ends up being, say, 25, right? So 5. Okay, so then that means that in the grand scheme of your quadratic formula, you're going to have plus or minus 5 somewhere. Not somewhere. You're going to have something here, something like that. This is just an example, right? These two could be anything. But we know we're going to have a plus or minus 5, which means we're going to have two solutions. So if your discriminant is any positive number, this doesn't have to be a perfect square, by the way. This could be like, right, square root of 31. I'd still have plus or minus the square root of 31, right? So if this is any positive number, then I'm going to have two solutions. So any positive number, I'm going to have two solutions or two x-intercepts. So that might just, since we're talking about it in terms of x-intercepts, that might look like this. This is the shape of a quadratic graph, by the way. We haven't looked at those yet. We're going to be doing that next week. But this is the shape of a quadratic graph. So I have something like this where it crosses the x-axis twice. If I get a positive number as my discriminant. All right, so what happens if I don't get a positive number, or how could I not get a positive number? Well, I might get negative 25. Well, if I get a negative here, I have to think, okay, what squared is negative 25? Well, that doesn't exist, right? Because negative 5 squared is positive 25. 5 squared is positive 25. I don't have a way to get a negative here. Later on, we'll talk about ways we can use stuff like this, even though they're not real numbers. But this tells me that I have no solutions. So if I have a negative like this, there's no way that I can get this with numbers that I'm used to using. So this would be no solution. So if what you get inside the square root is negative, then that would be no solution. So b squared minus 4ac is greater than 0. I have two solutions. It's greater than 0, positive, right? If, gonna get myself some space here. If b squared minus 4ac is less than 0, then I have no solutions. 0 solutions, no solutions. So that might be a situation like this, right? It's off above the x-axis. It never crosses it. So that might be a situation like that. If the discriminant is 0, that's the only other option, right? If the discriminant is 0, that's one solution. Because, for example, I might have 1 plus or minus 0 over 2. Well, that's just 1 over 2. That's one solution. So if the discriminant is 0, then that is one solution. So I'm going to first, to solve this, I have to first figure out what the discriminant is. So b squared, so b is 12, right? B is 12, so b squared is 12 squared minus 4 times a is negative 4, c is negative 9. All right, so 12 squared is 144. Negative 4 times negative 4 is positive 16. Positive 16 times negative 9 is negative 144, which is 0. So that is this third case where I only have one solution. So, get my mouse back. Discriminant was 0, so that's one solution. So this now, okay, I forgot to show you a picture of what that one solution looks like. So if it's just one solution, the discriminant is 0. This is going to be hard. This is where you barely touch the x-axis and then it goes off again. So it touches the x-axis at one point and goes off again. All right, so this is that second situation where we never cross the x-axis. So it got rid of all my writing here, but that was when the discriminant b squared minus 4ac is negative. So if it doesn't, if there are 0 times that the graph crosses the x-axis, then the discriminant is negative because you can't take the square root of a negative number. So it's going to be negative. Let's see. Okay. So let's do another one of these. So again, so negative 17 is b, so negative 17 squared minus 4 times a is 4 and c is 3. Negative 17 squared is positive 289 minus 4 times 4 is 16 times 4 times 3, sorry, is 48. So minus 48. 289 minus 48 is 241. So that's positive, right? That's positive. So how many solutions are we going to have? 241. We're going to have 2 solutions. So if positive, we have 2 solutions. Negative, 0 solutions. 0, 1 solution. And so that is how we figure out the number of solutions that a quadratic has without actually solving it. We're just using this discriminant to figure out how many solutions we have. We don't know what those solutions are, we just know how many we have. Yeah, I'll let you figure this out. Okay, so let me know if you have any questions, and I will see you guys later.